Okay, let's go ahead and talk about graphing linear inequalities. I just want to remind you a few things before we get started. If you just have a linear equation, so y is equal to 3x minus 2, we could easily graph this line. I'll start at my y-intercept negative 2, and then I'll go up 3 and over 1, and all I have to do is draw the line between those 2 points. Okay, so that's graphing a line. And then we had graphed one variable inequalities. Okay, and that was something like, x is less than 3. We had a number line in this case, just one dimension for one variable. We had some values here. So here would be 3. And we did an open circle because x was not allowed to equal 3, but it was everything less than 3. Okay, so 2.9 works, 2.9999 works, everything works except until you get to exactly 3, which doesn't work. So that's an equation because it has two variables. Okay, so we have an x and a y axis. So now we're going to kind of combine these two and do a linear inequality on the next page. Okay, let's say I have this inequality, y is greater than 3x minus 4. What we want to think about is this is going to be, for any given x value, there'll be lots of different y values that will make this a true statement. So let's say if x is equal to 1, then y just has to be greater than 3 minus 4, negative 1. Okay? So solutions would include, there's an infinite number of them, anything for y as long as you're greater than 1. So 1 comma 0 would be good, 1 comma 1 would be good, 1 comma 1.3 would be good solution, and so on and so on and so on. So there's an infinite number of solutions when x is equal to 1. So what happens is you end up getting the solution is what we call a region. Okay? So let me explain what's going to go on. We need to define the region with boundaries. Okay? So, in this example, y equals 3x minus 4 defines the boundary. So let's go ahead and draw the boundary of our region first by graphing this line. I'll start at negative 4, up 3 over 1, up 3 over 1. I want to be a little bit exact, so I'm going to do as many points as I can. Draw that line, okay? That's that line. Because you're not allowed to equal 3x minus 4, because it's only a greater than, there's not an equal, this is supposed to be a dashed line. So dashed line, if not equal. Okay, so I need to go back and make this a dashed line, and I can make some eraser marks, and I've got a dashed line. Okay, so now that dashed line, because I'm not allowed to equal the line, is my boundary. Okay, so which region? What I've done is I've divided this area into two regions. There's the region left and above the line, and then there's the region on the other side of the line, you might say to the right or below the line. So there's two ways to do this, how to test which is the correct region of the solution. And one of the things you can do is test a point, okay? So a nice easy one to test is 0, 0. So I'm going to test 0, 0, and ask myself, is 0, 0 a solution? So, is 0 greater than 3 times 0 minus 4? Is that a true statement? Yes, that's true. So 0, 0 lies in the solution region. Okay? So what we do to kind of mark this is we go ahead and shade that region. So you'll see all color shading in a book or something like that. And for us, you know, if you have a pencil, you can do a nice shading. For me on this app, I need to just come in and do a shading like this. So the shaded line is marking the solution region. So anything over there will be a good solution to that linear inequality. Let's just test it and see if it worked. Let's pick a point and test it. Here's a point that lies in my solution region. That point, 1, 2, 3, 4, negative 4, comma, 1, 2, oh, negative 4, comma 4, should make this original inequality a true statement. So is 4 greater than 3 times a negative 4 minus 4? Well, that's certainly true. So we've kind of just double checked that things are working. So as I said, there's an infinite number of solutions in that region. All right, let's try another example. Here's my second example. I want to try and graph this linear inequality, x minus 2y is less than or equal to 4. I'd like to start by graphing the boundary first. The boundary is given by the just equals. X minus 2y is equal to 4. So that's going to give me my boundary. Okay? So how do I graph that line? Well, it's a lot easier if it's in mx plus b form. So let me call this x minus 4 is equal to 2y. Divide by 2, of course. I get 1/2 x minus 2 is equal to y. So now I can easily graph this boundary line. I will make it a solid boundary line because I am allowed, there is an equal sign right there. Okay? So it'll be a solid boundary line. So let's do this. 1/2 x minus 2. Start at negative 2. Up 1 over 2. Up 1 over 2. Okay? And keep going. Solid line. I don't need to dash it. But now I need to decide which side of this line is the correct solution region. So let's do a test point. 0, 0 again is always the easiest one to test. So we're going to test 0, 0. Okay? So is 0 minus 2 times 0, is that less than or equal to 4? So the question is 0 less than or equal to 4? And you'll say yes. So again, it's true that this lies in the solution zone. So I'm going to shade on the same side as my 0, 0. If it's not in the solution zone, the region, then I would simply have shaded the other side. Okay? All right. Let's try to graph an absolute value inequality. And again, the same thing applies though. We're going to start by graphing the boundary. Okay, so the boundary is when you use an equal sign. Okay, y is equal to the absolute value of x plus 2. And we know how to graph this because we know the parent function, okay, is just absolute value of x. And we know that's a v shape with this point right here at 0, 0. And we know the plus 2 means to take this whole thing up 2 units. So let me draw that. I'm going to draw my v shape, slopes of 1, and I have my boundary. Okay? But then I want to go back and say, oh yeah, but I have to have a dashed line. Okay? I have to dash this line because not equal. Okay? There's no equal sign right here, right? You don't see an equals with the less than. So I have to go back and make it dashed. So hopefully my eraser thing will work. Something like that. So I have this dashed line, and now I just have to do a test point like we did before. I will test 0, 0 and see if that should be in the solution region or not. Is 0 less than the absolute value of 0 plus 2? We keep coming up this way, but I promise you it doesn't always happen. Is 0 less than 2? Yes. So 0, 0 is again in the solution region. So graph the same side as 0, 0 is on. So that's this side. Okay. So all of this, right, is good solution. And the only thing that's not is this part here, but inside the V is not part of the solution region. All right, so let's get one of these for you to try. Okay, why don't you try this one, y is greater than the absolute value of x minus 2, and that's all inside the absolute value. So of course you're going to start with the boundary line. You have to be able to graph y is equal to x minus 2. And how are you going to do that? You got to think about the parent function and the transformation. So this transformation is a, remember, right 2. Okay, parent function absolute value, so it's the V shape. It's just moved to the right 2 spaces. So go ahead and finish this up. Do a test point after the boundary line and do a shading. And let's check our work. Okay, so I moved my graph to the right 2 spaces. I used a dashed line because there's no equal to here with the greater than. And I decided to shade inside because a point outside, like 0, 0, is not a solution. It does not make that a true statement. And that's what my graph looks like. So we're going to do a lot more practice like this in class, and I'll see you then.